This talk is not entirely technical or at all technical, but it's my meetup group and I will speak about whatever I want to. So I'm speaking about thermonuclear war. So a while back I was in a meeting. It looked a bit like this. We were talking about this big installation we were going to build, this big system. And somebody in the meeting said, we need to have 2 data centers. They need to be either side of the M25, so they are sufficient distance apart that in the event of a thermonuclear war and a thermonuclear weapon going off and taking out one of the 2 data centers, our service can survive and will carry on. And I said, you must be joking, surely. And they said, no, we need to build it that way. Well, it turns out this thinking is actually in a lot of regulatory frameworks. If you actually think about this a lot, you have to have your data centers this far apart and have to build out this kind of thing. So, ladies and gentlemen, I present to you tonight operations in a thermonuclear war. This is a picture of Hiroshima. I went to Hiroshima a couple of years ago, and it's quite horrifying. The landscape still bears the scars of what happened there in 1945. There's kind of like warped trees, and this building is still standing. The reason that building is still standing is because the weapon actually went off directly above that building and pushed it down rather than out. Everything else basically got wiped out. So Hiroshima, that was a weapon of approximately 15 kilotons, 15,000 tons TNT equivalent. Little boy at Hiroshima. The thing to note here, this is not a thermonuclear weapon. This is a nuclear weapon. Okay? So a thermonuclear weapon is where you use a weapon a bit like this to start a reaction that is the sun on Earth. So, slightly scary. We started developing really thermonuclear weapons almost immediately after the first nuclear weapons. They took a while to develop. For the computer scientists in the room, it's quite interesting that we took almost a hiatus of 2 years. We were developing them up until about 1948, and then we took a break while we waited for people to build computers that were powerful enough to compute the thermodynamics required to actually ignite a thermonuclear explosion. So we just took a break for a couple of years, came back to it, thought, we'll carry on now. IBM have made some big computers, thank you very much. First thermonuclear explosion was this, Ivy Mike, 1952. About 3.5 megatons. The largest ever thermonuclear weapon, if my clicker worked, was Tsar bomber. This is in a Russian museum. This is physically a pretty large bomb. It can still be dropped from a plane, and it was dropped from a plane, to cause this explosion, which, as you can see, is so large it's going out into space. This is a big explosion. So, this was tested in northern Russia. This wiped the Kola Peninsula, a very large island, completely clean. This broke windows in Sweden and Finland. This echoed around the world 3 times. Fairly large bang. This, at full strength, is 100 million tons of TNT equivalent. It has so many zeros, I couldn't fit the extra comma in this gap. It's that big. Okay? It's a pretty big bomb. So, just to recap here, this was Hiroshima. This is what happened. 5-mile radius of everything flattened. 160,000 people died. That was 15 kilotons. The bombs which they came up with after that, the thermonuclear weapons, 100 megatons. So, quite a difference there. If you want to think what would happen if these things were ever actually used, there's a fantastic BBC documentary, like a faked documentary, a mockumentary if you will, about thermonuclear war called Threads. I recommend you look at that. It gives you an idea of just how horrific it would be if these things were ever used. The thing is, these things were never used. No human has ever used a thermonuclear weapon against another human, and yet we prepare for them, prepare for these things happening with these kind of very complex data center setups, etc. So what has happened is this. This was a GitHub outage that caused a big problem. This is from GitHub's blog, this quote, just basically saying they had 1 hour and 46 minutes of downtime and a further hour of big issues. This was caused by their high availability setup, designed to increase the availability of the system. Okay? So I've worked on systems where you've had 3 weeks of complete outage of a system because of the clustering software split-braining itself and corrupting all the data. So the moral of this very long story is please Keep it simple. Please don't over-engineer. Please don't engineer for operations in a thermonuclear war because it's never actually happened. Just do simple, manageable engineering, and hopefully this won't happen to you. Thank you very much.